Welcome to lecture 27. So in the last lecture we have started about the RAID technology, and we have so far learned about the three mechanism of RAID, that is the stripping, mirroring and the parity. So stripping is basically whenever there are more than one disk, it is make an array of data and make a total file system in a system. That is the stripping. Exactly copying one disk to another, it is called the mirroring, and the final thing is the parity is using for detection the errors. So today we'll go for the RAID level 2. So different version of RAID levels are basically come across because of the read and write timing and their performance issues. So RAID level 2 is basically across the similar of RAID level 0. It is just focused on the stripping levels, but there is some other disk is required here for ECC. ECC, that is mean error correction and detection. So monitoring the correction and also the detection the corrupted bits. So basically it uses some disk for the error correction to monitor the correctness of the information of the disk, and multiple disk records and the ECC information to determine which disk is in fault. So their different data are coming from different type of disk. So ECC is a disk which is basically matching with the data correction, that is the bits are coming with from the exactly accurate or not, and they're also having another disk of parity which is checking the errors. So basically the structure is like that. That is the data disk, it is block 1. That is another disk, it is also a data disk. So it is 2 disk. So there are, if you have 3 bits of data or 4 bits of data, so it is coming from 2 different disks, but the 2 different disks having some ECC disk also. Whenever you have read the data, you are checking with the ECC disk the data is correct or not, and also checking the parity. But whenever you need to write the data, you are writing some data in the data disk, then again you have to change the ECC disk and also the parity. So your level of working is going higher. So as you have 8 disk, in some hard drive, 8 hard drives. From here you are getting some 8 bit of data, that is 1 0 0 1 1 0 1 0. So these 8 bits are coming from 8 separate disk, and your parity is 0. That algorithm they are using, that number of 1 is even, then the parity is 0. If the number of 1 are odd, then the parity will be 1. So after the data read, they have found that 1 0 0 1 1 1 1 0. So a digit is changed, and there are 5 ones, so parity is not matched also. So that is why they are now checking with where in which disk the data is finding the problem. So if you thinking of from the right hand side, there are disk 1, disk 2, disk 3, disk 0, disk 1, disk 2, disk 3 up to disk 7. So if you are checking that this 0 is change this bit to 1, so disk number 2 having the problem. So if the disk number 2 having the problem, then ECC will change the disk according to the original data, and the parity will be matched. So just read the data and parity to know which bit to flip. So for this you have to maintain the ECC for the another hard drive for the correctness of the data. So requires fewer disks than the level 1 to provide the redundancy. Obviously, because if you need to have 8 disks in level 1, then you need another 8 disks for the exactly mirror copy. Here the disk number is lower than the level 1, that is true, but the big problem is the performance, because performance issue is must read the data plus the ECC code from the other disk. For each time when the data is reading, you have to read the ECC code for each of the times, and for the writing times have to modify the data, ECC code and the parity disk. So you have to manipulate it, or you have to work on 3 different disks. If you have just changed one single bit of data, it requires huge time. So read time is not the fact is the write time, and read time is also having the fact because you are reading some data with the ECC code and also maintaining the parity. So this is a big problem of the RAID level 2. In the RAID level 3, that is the basically the advantage of using the advanced technology hard drive. It is not basically the upgradation of RAID level 2 to 3. In the RAID level 3, there are new type of disk are already in the market. So these disk having the quality of determine if there is an error or not, that the data is already reading with the exactly quality or not. So the ECC codes with each sector is working properly or not, that is the RAID level 3. So it just needed the parity disk, it need not any ECC disk is required for the RAID level 3. So in the RAID level 4, in the RAID level 2 and RAID level 3, basically the big problem was the data interleaving. That is mean the bit problem, the bit interleaving was the big problem. To access a file, single file block of data must access all the disks and allow good parallelism for the single disk, but doesn't allow multiple input and output system. So as it is not allowed multiple input and output, so different disk having one time read and these data are coming from different type of disk. So the data is, as the data is coming from different type of disk, so there is some probability of missing some bits from different disks, and that's why the ECC code and parity are using for this technology. So here in RAID level 4, the interleaves blocks, interleaves is basically using the blocks, not the bit. So what is happening is here the still uses the single disk of parity, though we are just evolving, we are just removing the ECC code in the RAID level 3, but parity is still using. In the RAID level 4, we also using the parity, but with some different algorithm. So now the parity is calculated over the data from multiple blocks. So if we go for some example here, you will see that the level 4 versus level 2, 3. So if there are some data, A is a some data, B is a pattern of data, C having a different pattern of data, and D having a different pattern of data. These data are split into 4 groups and 4 parts. So A0, A1, A2, A3, and this is how D1, D0, D1, D2 and D3. So in RAID level 3, what is happening here, that each of the disk, each of the segment having A0, B0, C0 and D0, there are 4 different disks having the different data from different blocks, as they are working on the bit level interleaving, and they also having the parity of each of them, so that if some block of data is going faulty, they are XOR with the data of original and finding out that which disk having the problem. In the level 4, they are not using the bit level, they are using the block. So a whole block is occupied in a single disk, B having the data with another block of data, and C another block of data in another disk, and D having some block of data in another disk, but they are not using the parity with the same pattern. They are using some different algorithm to get back the original data in which block they are faulty. So read are simple to understand because the thing is happening with if some want to read block A, read it from the disk 0. So if some data want to read from the block A, it is just going for the block A and read it through from the disk 0. But the thing is that if there is an error, read in blocks B, C and D and parity blocks and calculate the correct data. So if there is some error, it need to read the block B, C and D, and with checking with the parity, then it found the original data of block A. But in the write, it looks like the write still requires access to 4 data disks to recalculate the parity data. Whenever you were just going to write, you need to reschedule the same data because the parity are not exactly the pattern of the data, it using some different algorithms. So some new parity, whenever you generate a new parity, you have to make some new formula like new parity is equals to old data XOR new data XOR old parity. So it's formulated a long type of pattern for the write and reads. So it requires 2 reads and 2 writes for generating a new parity. So it requires time, it requires more disk time, and it also requires some new configuration of parity. So the thing is basically the level 3 having some problem, the RAID level 3 having some problem because the bit can be missing and something can be happen in different segment of the data disk, but it having the quality of matching the parity in a shorter time. But in RAID level 4, it is having the advantage of using the all blocks of data in a same disk, but the parity whenever it making with some new algorithm, so it having the problem whenever the data is lost, it have to read the other blocks of memory and matching with the parity. But if the parity is not working, then the new parity need to be generated with the old data and from the new data and also XOR with the old parity. So is these mathematical equation requires more time because it needs 2 times of read and 2 times of write. So that is the RAID level 4. So doing multiple small reads is now faster than before. However, writes are still very slow. Write is not improving still. So this is because of calculating the writing and the parity blocks. Also, only one write is allowed at a time because it is working on some blocks. Okay, so all write must access the check disk, so other writes have to be wait, because here is one block is reading and one block is writing in the same time. This same time you are not allowed to work with the other blocks. So that is the problem of the RAID level 4. So that is the end of today's lecture. Thank you.